So today we're going to talk about greenhouse gases and the greenhouse effect. And when I made this PowerPoint, I put this title as Earth Really Warming. I don't like that subtitle anymore because I've decided to make that a secondary slide. Really, the subtitle of this should be the basics. So we're just going to go over the basics of greenhouse gases and talk a little bit about the greenhouse effect so you have background information. So when people talk about the greenhouse effect or the way that greenhouse gases work, it's important to understand the science behind it. So what happens is that waves can be short or long, and the short and long wavelengths have different energies. Short wavelengths have higher energy, long wavelengths have lower energy. So what happens is that from the sun, high energy, short wavelengths enter the atmosphere and they heat our surface. We know that, that's a good thing. We would be in a lot of trouble if we didn't have the sun heating our surface. But then the surface re-radiates some of that energy back up. So it gets reflected, re-radiated back up into the atmosphere. And some of it goes back up through the atmosphere and goes into space, but some of it is trapped. And the reason that it's trapped is because it's a low energy, long wavelength form. And this is easy to get trapped inside of the Earth's atmosphere because it has a lower energy, longer wavelength, and so it gets trapped. It can't as easily travel through the atmosphere. And then when that is trapped inside, that causes temperature on Earth to increase. So we're going to talk a little bit more about that. So here's a great diagram. I really like this one. Long wavelengths are coming into Earth, and then short wavelengths are bouncing back like this, and they're getting trapped within this atmosphere, and they're helping to keep the Earth warm. So what do we mean when we say a greenhouse gas? A greenhouse gas is a gas in the atmosphere that helps trap these long wave radiations. And there are many greenhouse gases, and many of them naturally occur in our atmosphere, and really we aren't responsible for initially putting them there. We add more to the environment, but some of them are naturally there, like water vapor, carbon dioxide, and methane. Those are common greenhouse gases that we hear about, and those naturally are in our environment. If these gases increase, though, it increases the amount of heat trapped in our atmosphere, and that's where we start to see problems. Here is a great diagram of the emissions of greenhouse gases worldwide over the past, in 20 years. And you can see this carbon dioxide is right here. We have this gas called nitrous oxide, which is another greenhouse gas. We have methane, and then we have these really terrible ones, these purple ones, called fluorinated gases. Those are awful. We're going to talk a lot more about those. But you can see that over the past 20 years, we've had an increase in every category. And so that starts to become a concern when we talk about greenhouse gases. Here is a greenhouse gas diagram for the United States. So of all of the emissions that we had in 2016, this is the breakdown of how much of it was each of those big greenhouse gases. So we produce 81% carbon dioxide of all of our greenhouse gases and 3% fluorinated gas. This fluorinated gas, like I said, is really bad. We're going to talk a lot more about it, but this is a real one that we are concerned about. We want that to be 0% for sure. So let's talk a little bit about carbon dioxide. Carbon dioxide is naturally produced by all living things, by all living things that breathe air, I guess. I don't know exactly, because obviously plants are living and they don't produce carbon dioxide, but human beings and animals, when we breathe in oxygen and we breathe out carbon dioxide. So carbon dioxide is naturally in the environment already in the atmosphere. But we can increase the amount of carbon dioxide in the atmosphere. And when we increase that amount of carbon dioxide, we increase the amount of greenhouse gases, and we increase the amount of heat that is trapped. So how do we not naturally produce these carbon dioxide gases? Well, when we burn fossil fuels or produce them, we create greenhouse gases. It's also produced when trees and other vegetation are cut down and burned, and it also can be made in manufacturing chemicals. And it can stay in the atmosphere anywhere from 50 to 1,000 years. Really, most scientists say, about 100 years. It's staying in our atmosphere and still having an effect. So we're still seeing the effects of carbon dioxide that were put into, oh wait, it's not, wow, I just thought it was the year 2016. Wow, it's 2019. So since 1919, we're seeing gases since that time. Wow, I can't believe I thought it was 2016. So here is a great graph. This shows us carbon dioxide emissions by source. So you can see that most of our carbon dioxide emissions are coming from the production of electricity and from transportation. So when we're driving our cars, burning gasoline, and when we're burning fossil fuels for our electricity, that's really where we're seeing those emissions. I really like this graph because it shows that carbon dioxide emissions in the United States have increased by about 4%. I know it's hard to see that in this graph, but between 1990 and 2016, there's a 4% increase in the amount of greenhouse gases. And since combustion of fossil fuel is the largest source of greenhouse gas emission in the United States, changing the way that we emit those fossil fuels is the best factor or the best way to control how much carbon dioxide that we produce. So we definitely want to decrease burning those fossil fuels in order to decrease our carbon dioxide emissions. Another one is methane, and methane naturally occurs in the environment. In some places, it's produced by wetlands. So when wetlands decompose, methane is a gas that is given off, but it also comes from raising livestock. And livestock, in the way that it's farmed today, they are kept in huge areas, and especially cows and sheep produce a lot of manure, and that manure, when it decomposes, gives off a significant amount of methane. Also, the decomposition of landfills gives off a lot of methane gas, and the production of natural gases in coal mining. So, it stays in the atmosphere for about 12 years, and it traps 20 times more heat than the same amount of carbon dioxide. So that's a lot more heat. So here's a great little graph. I like this one. It kind of shows you the primary sources of methane releases. The red bar is the minimum, so the minimum amount that it produces. You can see there are natural emissions of this, right? Here's wild animal emissions, termites. Those are natural processes. So methane is going to exist in our atmosphere always. We don't want to get rid of it, but we want to reduce it back to its normal historical levels. Here, this shows us what is producing our methane. Like I said, fermentation, landfills, and the production of natural gas are really the big contenders here. Methane emissions in the United States have actually decreased by 16% in the past 20 years, which is great. And while they've decreased overall, the emissions from things like agricultural activities have increased. The part that's making up for that is the amount of methane produced by landfills and coal mining is decreasing, right? We know that we're moving away in general from coal mining. Landfills are becoming more efficient and effective, and so we're seeing an overall decrease because of the proper management of those items. So another great one to talk about, I can't believe I said great one, but great. Let's talk about more greenhouse gases. This is nitrous oxide, N2O, and this is emitted during agricultural and industrial activities. It's also produced when fossil fuels and solid wastes are burned, and we mostly see, like I said, the production of N2O in agricultural soil management. So this is things like fertilizers, pesticides, those sort of things where we manage the soil are really where we're seeing nitrous oxide emissions. So that's, 77% of the nitrous oxide emissions in the United States are coming from these agricultural management practices. Over the past 20 years, there's been about a 4% increase in our production of nitrous oxide, and this is in part due to increase in emissions in agricultural soils and things like that. So the maintenance of those soils. And now, I talked about this one. This is the bad boy of greenhouse gases. This is the worst one. We hate this. This is the worst. And these are fluorinated gases. And the previous three gases that we talked about, carbon dioxide, methane, and nitrous oxide, all naturally occur in the atmosphere without human involvement. However, fluorinated gases do not. They are all man-made. They have no natural sources, and so they're really, really, really troubling. They're synthetic greenhouse gases, and they're really powerful. We produce them in not very large quantities, but they have a huge impact because they trap those long waves so efficiently and effectively. They really heat up the environment, and they're awful. And these are things like our hydrofluorocarbons. Say that at the dinner table, and your parents are going to think, wow, you're so smart. The perfluorochlorine, I can't even say it. Perfluorocarbons, sulfahexafluorides, and nitrogen trifluorides are all parts of these fluorinated gases. Notice they have this fluoro in here, which makes them fluorinated gases. So these are bad news. Can't say that enough. So why are fluorinated gases produced? Well, the main reason is that we were trying to save our ozone, right? We know we had an ozone layer problem, and we know that that's starting to get better. And these fluorinated gases replaced those gases that were produced by ozone depleting substances. So we tried to fix one problem, we tried to help our ozone layer, and what we've done is we've created another secondary problem in creating these fluorinated gases that trap so much energy inside of Earth. And we see that happen sometimes, right, with humans. We see, oh gosh, there's this problem, let's try to fix it. And then we think, oh my goodness, we created this other problem. Like, how could we have done this? So really, the primary reason, 92% of the gases that are produced is because we're trying to fix this ozone problem, and we're trying not to use gases that harm the ozone. So really the most troubling thing about this is there has been a 74% increase in these really awful gases since 1990. And like I said, we, over these past 20 years, have really tried to fix our ozone layer. And so we were like, yes, fluorinated gases, they're the solution to our problem. And we're now discovering that, gosh darn, they really aren't as great as we thought. And so, it's a big problem. So what impacts a gas's impact on the climate? Well, really three things. How much of these gases are in the atmosphere, how long they stay in the atmosphere, and how strongly do they impact the atmosphere. And we look at how strongly they impact the atmosphere through this thing called global warming potential, or GWP. And we're going to talk about that more in a little bit. But obviously, the longer that gases stay in the atmosphere, the more harmful they are, and the more of these gases, especially those fluorinated gases that are in the atmosphere, the more dangerous they are. So let's talk about this global warming potential, this GWP. So this was developed by scientists to allow us to compare global warming impacts of different gases. And what this does is it measures how much energy the emissions of 1 ton of a particular gas will absorb over a given period of time relative to 1 ton of carbon dioxide. So carbon dioxide is kind of our comparison when we're looking at these GWPs. So because carbon dioxide is our comparison, we say that the GWP of carbon dioxide is 1. Methane, our GWP is 28 to 36 over about 100 years. So that's 28 to 36 times more potent and powerful than the trapping power of carbon dioxide. Nitrous oxide is almost 300 times more powerful at trapping gases, and it will stay in the environment for about 100 years. But truly, and I can't say this enough, the most disturbing gas, greenhouse gas, is this fluorinated gases, because its GWP is 15,000 to 23,000. And while these other ones are over 100 years, these are over 1,000 years, and sometimes 1,000 years plus. So this is just, like I said, bad news bears. We don't like it. Here we are crying because we're so sad about these fluorinated gases, especially since they're up 74% in the United States. They're a big problem. So what can we do? Well, first of all, we need to plant plants. Carbon dioxide is needed for plants to go through photosynthesis, and the more plants that we plant, especially trees, the more carbon dioxide gets fixed into the soil and is taken out of the atmosphere. This should really say atmosphere because it's still in the environment, but it's just in the atmosphere now. We need to definitely work on conserving energy and being more energy efficient, and work on using more appropriate fertilizers and processing manure correctly.